Welcome to 8.4 Compound Interest, Part 1. So last video we talked about simple interest, all right? So that's a nice place to start to understand what interest is, but usually when we invest money or we borrow money, they do not use simple interest, unfortunately. Instead, they use what's called compound interest. This is nice when investing because it means that not only does the money you put into an account earn interest, but so does the interest dollars that keep getting added to your account periodically. So your interest is earning interest, which is earning interest, et cetera, et cetera, et cetera. So when we compound interest, or compounding interest, is when interest is computed on the original principal as well as any accumulated interest. So that's different than simple interest, okay? A compounding period is the period of time between two interest payments. All right, so let's just kind of walk through this example really quickly. So suppose you put $1,000 into an account that makes 10% interest. If the interest is compounded annually, how much is in the account after the first year? So we're just going to use that simple interest formula, okay? So the simple interest formula, and we'll kind of zoom in here. So remember, simple interest is the future value is equal to the principal times 1 plus the rate times time. So in this case, our principal is 1,000, our rate is 0.10, and our time is 1. So after the first year, we have $1,100 in the account. Now, how much is in the account after the second year? So if we use compounded, or if this is compounded annually, meaning now I get to compound what I had previously, which is this portion right here, and now we're going to add interest to that, okay, which is this second portion here, all right? And what we would get is we would get 1,210. Another way we could write this is 1,000, our principal, times this 1 plus our rate times time raised to the second, because it's sitting in that account 2 years. So how about after 3 years? Well, now we just add, or we simply multiply by that 1 plus 0.10 times 1 again, because we're earning interest each year, okay? So another way we could write it is 1,000 times 1 plus 0.10 times 1 raised to the third, because it's sitting in there for 3 years and it's continuing to earn some interest. And so we would get 1,331. So in general, okay, what can we say? Well, generally speaking, if I have an account sitting in there for 10 years, for T years, I would simply rewrite it as my principal times 1 plus my rate times time raised to that T, okay? So that's getting us into this kind of formula here, where if it's compounded annually, that's kind of key right there, is it's compounded annually, then we have our formula. A equals P times 1 plus R raised to the T, okay? Meaning at the end of each year, it compounds the new interest. P is the principal, A is that future value or the amount in the account, R is the annual interest rate as a decimal, and T is the number of years that it's sitting in the account. So let's look at this first example here. Assume you put $1,000 into an account that earns 8.7% interest. If the interest is compounded annually, what is the future value in 20 years? Well, if it's annually, I can think of it as this, P times 1 plus R to the T, or that's where that times 1 comes into play. So we have 1,000 times 1 plus our rate raised to the 20th power, because it's sitting in there for 20 years. At the end of 20 years, that's how much money is in the account. Not bad for not touching it for 20 years and not doing any work. So how do we determine the interest that's earned? Well, we take what that future value was at the end of those 20 years, and we subtract the principal from it. So that is the amount of interest we earned, okay? Now, one thing I want to note is notice this time on your calculator, what you should have had is this value over here, 5303.845708. Well, why didn't I round up to 85 cents? Why did I leave it as 84? Because when you're investing, you don't get to the 85th cent until it literally says 85. So when you're investing, you cut it off after the cent decimal. Okay, so if I'm looking at my calculator, I don't even look at those values to the right of my second decimal. I cut it off at that second decimal as is. Versus when we're taking out a loan and we have to pay back that interest, then I round up. So borrowing money, we round up. Investing money, we round down. Using the same example, what is the future value in 40 years? So now all I'm going to do is P times 1 plus R to the T, where T is 40 this time. So we throw it in, and again, notice I am not looking past my 2 decimals, my second decimal place. I'm not rounding that up to 78 cents. We're cutting it off at 77, okay? All right, so how much interest was earned over those 40 years? Well, I take my future value after 40 years, and I subtract my principal, which was 1,000. So after 40 years, you've made over $27,000. Not bad for having it sit there and doing nothing. Okay, but what if I just wanted the last 20 years? Okay, well, remember from example B, the first 20 years, we earned $43.03 and 84 cents in interest. Okay, and the last 40 years, the entire 40 years is we earned $27,130 and 77 cents. So we take the total amount of interest and we subtract the first 20 years of interest, and we get this much interest, $22,826.93, simply in those last 20 years. So the longer you let it sit, the more it grows. All right, and basically that's an exponential growth. So comparing those interests, it grows exponentially the longer it sits there. Typically though, when you invest money, it is compounded more than just once a year. All right, so some accounts compound interest more frequently, and that's only to your benefit when you're investing, right? So if we're going to talk about compounding annually, we could go ahead and say that N, the number of compounding periods per year, is 1. And that's 12 months if we wanted to talk about it in terms of 12. Semi-annually, that's N is 2, twice a year. And you can see the months that go by. Quarterly means it's compounded 4 times a year. Monthly means it's compounded 12 times a year. Weekly, it's compounded 52 times a year. And daily, again, we're going to use 360 days for a year, even though we know it's not, but that's just going to be what we use in this chapter. So N is 360. All right? Remember, the interest rate that is reported is always for the year. We don't change that though, okay? So if the money is being compounded more than once per year, we typically split the percentage equally for each of those compounding periods. So for instance, if an account earns 12% interest and is compounded quarterly, what is the quarterly interest rate? We would take our rate, we would divide it by the number of times it's compounded, so 0.12 over 4, and the quarterly rate is 0.03, okay, or 3%. Now, how many times will interest be compounded in 10 years? Well, we take the number of years it's sitting in an account, and we multiply it by the number of times it's compounded each year. So T times N, and in this case, it would be 40 times. So what's happening is this is leading us into our compounding interest formula when interest is compounded N times per year, okay? So instead of just that 1 plus R, it's 1 plus R over N, okay? And then instead of just being raised to the T, it's raised to the N times T power to help us figure out how many times it's compounded, etc. Okay? So all of the other letters don't change. P is still our principal, A is the future value, R is that rate, T is the number of years it's sitting in the account, and N is the number of compounding periods. So let's try another example. Okay, so suppose we want to know what is the future value of $1,500 if it's deposited into an account earning 5.4% compounded quarterly for 20 years and then for 40 years. And then let's compare the interest. All right, so in 20 years, just plugging into that formula, and again, the formula can be seen right below. It's this guy down here, okay? So we have 1,500 times 1 plus our rate over n. It's compounded 4 times each year, and we raise it to the 4 times 20 because it's sitting in that account for 20 years. Throw that onto your calculator, and again, we don't even look after the second decimal. Okay, so we cut it off after 2 decimal places, and we get $4,385.22. If we're now comparing that to the 40 years, I'm simply changing the time that it's sitting in the account. So 1,500 times 1 plus 0.054 over 4 raised to the 4 times 40. And then we get $12,820.10. Again, looking at my calculator, I cut it off after 2 decimals, and we don't round up, okay? All right, so then we need to talk about interest. Well, how much interest did we earn on the first 20 years? Well, we take our amount of $4,385.22, and we simply subtract $1,500 from it, and that's where we get our answer here. But what about the second 20 years? Okay, so first I need to figure out, well, how much interest did we earn total? So I'm going to take $12,820.10 and subtract $1,500 from that. So when we do that, we get that amount of $11,320.10. And then we're going to subtract what we found, or the interest we got from the first 20 years, and then we can go ahead and say, well, the last 20 years, we managed to earn $8,434.88. The last thing we're going to talk about is continuous compounding. Now, I can go ahead and you can walk through this kind of on your own. I'm going to skip through it really quickly, but what it leads you to is continuous compounding means that we're going to be compounding periods increase infinitely, meaning I am compounding over and over and over and over again, trillionths of a second, quadrillionth of a second, that many times. So over and over and over again, nonstop. So when we're calculating the amount in an account for continuous compounding, so that's kind of key, continuous compounding, I need to see that, we are going to use this formula, and I call it PERT, okay, where E is this irrational number, okay, and you have a calculator key that is E. So you got to find that on your calculator. That's what we're going to use, is just like pi, but we have an E key. So it's equal to A, or A is equal to P, the principal, times E, which is just an irrational number, raised to the rate times time that it's sitting in the account. Okay? So P principal, A is future amount, R is your annual interest rate, T is the number of years it's sitting there, E is this irrational number. We use the E key. This leads us to our final example for this set of notes. So if a loan for $2,000 is taken out at a rate of 4.3% for 5 years, and the interest is compounded continuously, I have to see that phrase, and then I know that I'm using PERT. How much will need to be repaid at the end of 5 years? So again, I see this compounding continuously. I know we're using A equals P times E to the RT. Okay? So as we go through, all right, the loan is, the principal is $2,000. It's compounded continuously, so I know I'm going to use that E key, raised to our rate, 0.043, and it's sitting there for 5 years, or we have to repay it in 5 years. So at the end of 5 years, how much do we actually owe? We owe $2,479.73. Now remember, why did I round up this time? Looking at our calculator, we should get this value over here on the right. But notice I didn't put 72 cents. I put 73 cents because loans, we round up, okay? Loans, we round up always, no matter what that last value is. It's a 3. We don't round. We do. We always round up. If you have questions, let me know.